I gave you all kind of examples of how rank dependence can be used to capture empirical phenomena, but it was still quite in theory and principle. I want to continue doing this, but bring in more empirical realism. And one of the first questions to ask, well, I hope I convince you that this probability weighting function is a useful concept to add to classical theories. And then, big question, what do they look like in reality? If we do measurements of them, what kind of shapes do we see? So I want to discuss that now for you, and I'll bring up some typical shapes and what they mean. First shape, here we have it. This is probability weighting function, just a diagonal identity function. Probabilities are not transformed. That means this is just expected utility maximization. Well, that is a special example of rank-dependent utility. It can happen in practice. I, in fact, think it's the rational thing to do. But anyway, this is one example to start with. The second example I put below, and this is a probability weighting function that is underweighting all the probabilities. We've seen this shit before, already tried to give you some intuition that this is pessimism. This is typically the probability weighting function of a pessimistic person if you underweight all the probabilities. Now I put up another shape up here, and this, at first, when you see it, at first you think, what weird thing is that? Would there be anything in nature like that? First concave, then convex. Now what is it? Well, it turns out this is found, in fact, this is the prevailing pattern that we find. It's inverse S-shape. I want to take a bit of time to explain to you what the psychology is that is captured by this. This is a decision maker who is insufficiently discriminating between intermediate probabilities. The function is too shallow here. If the probability increases by an amount, the weight does not increase sufficiently much as it should, too little. Well, we have normalization. This always goes together with the function being too steep at the endpoints. It's a sort of categorical thinking. Big difference between impossible and possible, for instance, and intermediate. There's not much distinctive power. I think the case becomes clearer if I show you an extreme example of this kind, and here it is. Here's an extreme version of inverse S-shaped. I know the function is not strictly increasing, but give me that one. Anyway, here is a person who has a sort of three-valued logic. This person says, the function is 0 at 0, it is 1 at 1, and then everywhere in between it is half. So this person says, either you know that something does not happen, or you know that it happens, or you don't know. And if you don't know, you can call it 50-50. This person has only 3 levels of thinking that they're capable to distinguish between, and this person is not able to distinguish between different levels of likelihood. It doesn't mean that the person is oversensitive to change from impossible to possible, or here the change from possible to certain. The person is very sensitive to that and not sensitive to any other changes. So this is more categorical thinking than continuous thinking. This is quite primitive perception of risk if people have a probability transformation function of that kind. In reality, this curve in the middle is a sort of mix between the left one, perfect sensitivity, and the right one, no sensitivity at all. We do have that the function is too shallow here, too little discriminatory power, and we do have that the function is too steep here, it's too much this categorical distinction between impossible and possible, and the same kind of story here. But it didn't completely lose sensitivity. It's still continuous and still increasing probability does increase decision weight. But this is sort of not total absence of sensitivity, but insufficient sensitivity. The first, 2 more figures will come here later. But anyway, changes in that dimension, making the probability lower or maybe higher. Such changes have to do with liking or disliking risk. It's what psychologists would call motivational, how much you like or dislike it. For instance, this is pessimism. It does mean that people have a dislike of risk. The pessimism makes people more risk averse. That's about liking, disliking, motivational. But we have this other component, other dimension of more or less inverse S. This is different. This is not about liking or disliking. It's more fundamental. It happens before any liking or disliking. This is a lack of understanding. This is just people don't understand how different probabilities in the middle region are. They have insufficient discriminatory power. Maybe you remember from the medical example, there was a probability 0.21 and 0.24. And one problem in this example is that people often don't understand how big that difference between those two is. People think too much, oh, they are similar, it doesn't matter much. So it's more about knowing, which is what psychologists call cognitive. And in reality, both of these things carry on. There are motivational components and there are cognitive components. I put up another figure. This is a combination of that extreme insensitivity, but also pessimism. So this person, if you do neither know if something happens or you don't know it does not happen, there's neither of these, you just don't know, then it's always the same to that person, but the person is very pessimistic about it. So always give very low weight to it, very quite dislike. It's a combination of that extreme insensitivity and pessimism that this figure is capturing. Now, finally, this figure captures the prevailing empirical finding. I already told you inverse S is prevailing empirical finding, but it's combined with pessimism. What you find in empirical reality is the inverse S shape, but everything is pushed down. So it's a combination of insensitivity and dislike, pessimism. Both of these are going on in the human minds. It does mean the intersection point of the diagonal is now not at 0.5, but it's lower at 0.3. And maybe if you compare a bit the effect of pessimism and this insensitivity for the small probabilities, they are opposite. Pessimism makes you underweight, insensitivity makes you overweight. But you find a combination, but there remains a bit of overweighting. So usually the small probabilities are still overweighted a bit, but then the middle and the large probabilities are underweighted, and the underweighting is quite stronger than the overweighting. Because for these probabilities, the large probabilities, that's the big rank, mean bad ranks, the bad outcomes. There, inverse S and pessimism work together in the same direction and reinforce each other. So you have a lot of pessimism here and a bit of optimism here. That is the prevailing empirical finding. Now, this inverse S is nobody ever, for theoretical reasons or whatever, invented this inverse S shape and let's do mathematics with it. No, the empirical data have imposed it upon us. When first people started working on rank-dependent model, quick in the early 1980s, and people, they were mostly interested in these kind of things, risk aversion, pessimism. That was in a way the only thing that they had seen. But simply the moment we started collecting more data, more empirical realism, the data just showed to us. It is not always like that. It's more like this. Simply empirical reality imposed inverse S upon us. And now it is our task to develop a theory. Our behavior always want to combine empirical realism with theory and even mathematics. So it is our task that in empirical realism imposed upon us to develop theory understanding of inverse S. And it already starts with how do you define it formally? Well, you can say it vaguely in word, but how mathematically, well, there have been attempts in the literature, and the preferred one I will present to you later, but it already starts with that. And then what is more or less insensitive, all these things have to be developed. So that is part of behavioral. You have to know more about psychology and empirical, but you also have to be a better mathematician than your classical colleagues, because all kind of new and more difficult maybe problems come up. Not we do it. Now, pessimism, the shape here, this can be captured with convexity, the opposite for optimism with concavity. And mathematicians, they filled libraries, their own books, and people who all their life study mathematical properties of convexity. So there's a lot of that. But for inverse S, I don't know about it. So that has to be developed new, and that is coming. I will start in the next slide by giving the definition of inverse S.